In the first lecture, if you remember, when we were describing the course outline and so on, we described the ABET student outcomes, right? Alhamdulillah, all your courses in engineering are ABET certified. Now, one of the major targets of which are written by ABET or by any other organization or author which writes about what should be the characteristics or the traits or the capabilities in an engineering student once he graduates, he or she, right? Graduate attributes. One is called lifelong learning. That you see, here there were classes and professors and labs and teachers and then exams. In the rest of your life, the education should continue. You should become independent. So when you say lifelong learning or you say independent learning, then they mean roughly the same thing. That later on you join a job, you have to learn new technologies, new techniques, you have to make your own decisions. You come across a problem which was not there. You study about that problem yourself, you try to develop a solution yourself. So that capability of being independent is important, right? So now you see this heading of reading assignment. So this is still the introduction chapter. It is like reading a storybook with a lot of interest and a lot of enthusiasm because it is talking of science and engineering and manufacturing and so on. But some portions of the course, if everything is prepared by the professor and explained to you, and then you only respond, then you are like in a school type atmosphere. But some things that you see, this is a small portion, you read it yourself, you understand it yourself, you discuss it with your friends. Of course, in the online session or the question answer session, you can ask about it, but this you do independently. So a small portion you learn by yourself so that your lifelong learning skills or your independent learning skills develop, right? So I want to do that from time to time. And you are now not in a basic year. The first 2-3 years of your university are over. You are almost in the second last year, right, in manufacturing. But one thing I've already done, I could have just given you the topics that in the introduction chapter. These rest of the topics you do yourself. But what I have done, I have made the slides also. So, right, so product design and concurrent engineering and development process, right? So just read this yourself, whatever is written here, and try to understand it. You have done a product design course or you are doing it, and you know manufacturing and so on. So what is the relationship between design and engineering? What is concurrent engineering? Here, design for manufacture, design for assembly, design for disassembly, design for service, shapes and manufacturing processes, right? So this is the topic. You can read it quickly in the book. Here it is summarized that these are the shapes or features and these are the methods by which they will be produced, right? So so you have to design for manufacturing at the time, you have to design for assembly, and therefore which shapes can be produced by what type of manufacturing processes. Design for assembly. So lots of examples of good and bad design, different. So just go through them, try to understand them. If you don't understand any one of them, then you can go somewhere to the book or so on, okay? Environmentally conscious design, sustainable manufacturing, product life cycle. As an example, we are giving an all aluminum automobile of the future. All aluminum, there is nothing right now, but in the future it could be. So in design and manufacturing, you think of the environment, you think of what is sustainability, you think of the full life cycle of the product rather than only the time of the designing and manufacturing. So think about it, read on. Selection of materials, right? for a certain design, for a certain manufacturing. What are the types of materials, material substitution, their properties, cost availability, service life. So go to the book, go to the net, wherever you want. And for each of these, at least 1 or 2 sentences you should know, right? You think about it yourself, that what does material substitution means, and what is the role of material properties in selecting of materials for manufacturing, right? And so on. Selection of the manufacturing process, not selection of the material, selection of the manufacturing process. For example, this is a shape that you are producing. But if you see A, you are producing it by casting or powder metallurgy. B, you are producing it by forging or upsetting, and so on. So same shape you can produce by lots of different manufacturing processes. So think about it, that this particular shape, how will you produce it in casting? How will you produce it in machining? How will you produce it in extrusion? And then how will you select for a product, that if I have a product, then why should I make it through casting? Why should I make it through forging? Right? So think about it. Scales in manufacturing. A scale means size, right? So if you see here, from dust particle to virus to cell to mouse to human being, size. In manufacturing, lithography and so on is printing, to machining, to forging, to casting, big parts. In applications, integrated circuits, gears, packages, machinery gears, automobiles, aircraft, size, right? So think about it. Nano manufacturing, meso manufacturing, micro manufacturing, macro manufacturing, right? So this is the classification of manufacturing based on size. So think about it. Computer integrated manufacturing, CIM. What is it? What is computer aided design, CAD? What is computer aided manufacturing, CAM? What is CAD CAM? What is CIM? Example, machining a mold cavity, but by all these methods and so on. So quickly try to find out. This is the most modern method of doing it, involving computer in everything. So, right, the operator is not there now. The operator has been removed by a computer program. So think of what is computer aided design, computer aided manufacturing, computer integrated manufacturing, and so forth. CAD CAM is an elective course that we offer. CIM is an elective course that we offer, but you have to have a very quick idea of what it is. What is flexible manufacturing? Flexible manufacturing system. What is this, right? So we are showing you now a whole factory rather than individual machines. So the previous slide was computer aided design and computer aided manufacturing, that each machine is a computer numerical control machine. But now there is a whole factory of computer numerical control machines, and it is run by robots and so on. So this is flexible manufacturing. So quick idea. Lean production. What is lean production? What is agile manufacturing? What is quality assurance? What is total quality management, TQM, right? So lean manufacturing, agile manufacturing, quality assurance, total quality management. Have a very quick idea of what these things are, because they are all directly related concepts to manufacturing. Manufacturing cost, right? It is very important in selecting a manufacturing process and running it, that what is the manufacturing cost. So this is just rates. Of course, this was published in 2004. So this is like 15 years old, but still, right? Denmark, Norway, Germany, Belgium, Switzerland, United States, and so on. What are the rates? So this will give you a very general idea that if a country is very advanced, then yes, it is advanced, but the labor rate there is higher. So the cost of producing something there will be more. That is why, right, many modern countries start setting up operations in Asian countries and African countries, that we will be setting up the plants, but the locals will manufacture it under guidance by us. The cost will be low. So these are some of the topics. I have already prepared the slides for you, which is reading assignment. See, if I say that some part of the book is not covered, it is not covered. But when I give it as a reading assignment, then it definitely means that You read it, you understand it. If there are any questions, you can always ask me in an online session. But then they are definitely included in quizzes and exams and so on, right? So this is important that you really try to understand it. This brings us to the end of chapter 1. Welcome to the fascinating and exciting world of manufacturing processes. This is not, just that I am saying it, but hopefully in these beginning days of the course through this introduction chapter, we have succeeded in doing the two things that we intended to do in the beginning, that we excite you about the subject. We make you feel that you are in this subject, not because it is in the degree plan and not because you have to do it, but because for every engineer, manufacturing is the key, is the backbone, is the fundamental target of all engineering, is to manufacture and produce products. So it is very, very important. So this important thing and the excitement that you are doing something really good. And the second part, that you have an overall idea of what is manufacturing, what are the different processes, how are they related, what are the current issues in the world, right? And let me again repeat myself that as a professor, as a teacher, as an instructor, my target is that at the end of the semester, you should have a very good knowledge, basic knowledge, of course. This is the first course. I am not talking of master's or PhD level, but you should have a very basic, good knowledge and thorough understanding of manufacturing. So this is one target. And second, that you get a very good grade, inshallah, right? So these are my two targets. And if you work with me, right? If you work with me, if you interact, if you respond, I will try my level best to try to explain every topic in as much detail as I can, as clearly as I can, to show you the solution processes and the methodology very clearly, to have very good examples, to hold tutorial sessions. So from my side, I will try to do my level best so that you learn this course well. But then you have to respond, right? Every lecture, before the next lecture starts, you should revise it. You see, you have gone through the lecture notes, you have gone through the video lectures. It is fresh in your mind. So before you come for the next lecture, if you revise it, within 25-30 minutes, you can revise everything. But because you have revised it once now, so everything is very solid in your mind. And when you go to the next lecture, then you understand much more. If you leave 2-3 lectures, 4 lectures, and start revising at the time of the first quiz, then there is too much material, there has been too much gap. Now for revising the same amount, you will take a lot of time. So if you want to spend a little time on the course, then do this time management well, that between the lectures, revise them quickly and do the practice. And if you do this, then you are also well prepared during the online sessions for questions and answers. If you have not gone through the lectures well, then you will not be participating with me in the lecture part. So if you interact and participate, then hopefully at the end of the semester, you would be very good in the knowledge of manufacturing processes, and your grade will also be very good. So thanks for now. See you next time. Ma'as salama.